going to prove the theorem of why when you take a mixed number and you multiply c by a, which is right there, and then you add the b and divide by c, you get the right number. The first thing you have to realize is that a and b over c is their sum. It's a plus b over c. And whenever you add two numbers and at least one of them is a fraction, you have to get common denominators. And the common denominator will simply be c. I'll change a by multiplying it by 1 as c over c. Now, in addition, I have the same denominators, so I keep it and I just add the tops. A, C plus B. There it is. Since this is an arithmetic proof, why don't we also show it with numbers? If you have 2 and 3/5, this means 2 plus 3/5. And you get a common denominator, I'll multiply this number over here, top and bottom. And then you get 5 times 2 plus 3 all over 5. 2 times 5 is 10 plus 3 more. You get 13 over 5. But let's look at this a little bit more closely. Whatever number is here, it stays, well, let's go here. It stays as the denominator. Okay? You have 2 plus 3/5. Now, let me just erase this because of that purple marker. Now, the rule says that you multiply the 5 by the 2. Well, yes, you do. Because in getting a common denominator, it's going to be whatever that number is over itself. That's what you multiply the 2 by. So we keep the 5, and then it turns out that whatever this number is, you multiply it by the number in front. Whatever number that is, you multiply it by the number in front. That's how I got the 10. And then you add the numerator, which in our case was 3. And you get what you get, 13 over 5. Another example, you got 7 and, 3/4. This is 7 plus 3/4. Now, in order to have a common denominator, whatever this denominator is, I multiply the 7 by 4 over 4. So now we have, in addition, the denominators are the same. What's same? This one. That becomes the denominator. And then whatever this number is, you multiply it by 7. By 4. Whatever number this is, you multiply it by 4. Where did the 4 come from? Here. The only reason we wrote 4 over 4 is because of that 4. And that 4 ends up on top and gets multiplied by the 7. So you get 4 times 7, 28 plus 3. You get 31/4. 4 times 7 is 28, plus 3 more is 31 over 4. The rule works. And we proved it in general. We proved it for an arbitrary mixed number. Now, one last thing. When you have 2 and 3/4, this is not 2 times 3/4. You can write 2 times 3/4 the way I just did there, or you can say 2 times 3/4. Or if you prefer, you could even put the 2 in brackets. 2 times 3/4. But 2 and or 12 and 7/11, this is not 12 times 7/11. What it is 12 plus 7/11. Don't get the two confused. There either has to be a time symbol or brackets, parentheses. Just like when I write down the number 72. This is not 14. I mean, why not? I mean, why not think of it as 7 times 2? And we have this agreement that there's 2-digit numbers, and how else are we going to write 2-digit numbers and 3-digit numbers other than 2 numbers side by side? Just like this. 2 numbers, 12 is a number, and 7/11 is a number. It's addition. You may say, well, I don't see addition over here. Well, there you go. That's 70, and you're adding 2. There's your addition. This is 12, and you're adding 7/11. Okay, that completes this video.